Go ahead and start this stripping and soldering a mic cable. So I'm going to start with my wire strippers on the microphone cable. For me, it's about a pinky's width length away from the edge. I'm going to go ahead and start to score and turn the microphone cable to start to get rid of the black insulation layer, okay, or the jacket, okay. At which point, get all the way through that side. Boom. Inside the microphone cable, you will find a braided shield. Okay? And I warned you yesterday that typically I will not braid the shield or pre-tin the shield. Okay? This one is a different type of microphone cable. It has something else with it, and I will lose the braided shield completely, so I don't need to worry about it. But braided shield, if you look at it closely, resembles a
Chinese finger trap.
Chinese finger trap, which until last year I didn't really realize. So it's a pain in the butt to try to unwind if it's fully extended. So I'm actually pushing on the end to try to get it to expand, because that's how you get out of a Chinese finger trap thing, right? Okay, so it starts to loosen up, which is a good thing, because now I'm going to take my screwdriver and I am going to slowly and carefully unbraid it layer by layer so that I can unbraid it in very much a single short line going down. Okay, how far down? All the way down to the black insulation jacket, right? All the way down. Okay. And this is why I'm trying to be careful, because right underneath the braided shield there is this thing that we call a drain wire. Drain wire, drain wire, drain wire. Okay? Underneath the drain wire is this tissue paper. Okay? But I'm going to go ahead and take my braided shield now that I've so carefully unbraided down one side, and I'm going to bring it to the opposite side, twist it, and cut it off. Okay? So now I can take my tissue paper that was there and pull that straight away off. There's my drain wire. Now I have two strings, a red wire and a black wire. Strings I'm going to cut off as well. What are the strings for? The strings actually give some depth to the cable, and when you look at it, it looks nice and round. What good would it be if it looked like one of those old extension cords? Right? Flat, ew, yuck. No, right? And the strings also give it a sense of stretching stability. Right? So ideally, the strings will absorb most of the strain of being stretched as opposed to the actual wires. Can't really verify that one. I would think that the wires themselves pull more of it. Okay, now I'm going to strip the red and the black wires. Okay, how much?
Not much.
Not much at all. Thank you, Eric. Right, so there it is. Strip one, strip two. Boom. Not much stripped off. Okay, at which point I pre-tin up all these things. So I'm going to go ahead and pre-tin up this drain wire, pre-tin up my black wire, pre-tin up my red wire. Okay? Do a quick clean of the tip. Life is good. I happen to be on the female side. Notice that the shell is on the cable first. Big bold words in the notes. Pre-tin the, or no, put the shell on the cable first. All right, on the connector itself, even though I've got plenty, I'm going to just demonstrate quickly. I want to apply some solder into the cups. Okay, that's pre-tinning the terminals. So I lay my soldering iron in there. Look, some of it already went, and then I would just apply a little bit of solder. Great. Let it heat up so that you see everything melt in, right? So that when you actually pull it out, it's nice and shiny and smooth. Good. So now I have solder on the terminals, I have solder on my conductor, on my conductors. Life is just grand. Now, in the notes you should have read, because we read the notes, right?
Yeah.
Occasionally. That there is an order of how we put these things on. Well, not an order, but a method, okay? Because I'm working with a red, black, and a shield, I'm going to automatically assume that the red represents my hot signal, the black is going to be my low signal, and obviously the drain wire is going to become my shield. On the connector itself, they have numbers, which, because mine is so old, and I'm sure students have used it before, is all melted to heck. But on the female, I'm kind of good because I know that the shield is the one that's really, really low. And I still need more caffeine. I'm still shaking. All right, so I heat that up, let it go, and try not to shake too much, and mostly solve it. Cool. Okay? So my shield goes into number 1. Where does the red go? It goes to number 2. Who came up with that idea? Wouldn't you think that the hot should be 2? So I'm going to go ahead and bend the wire around, so that it will lay in the cup nicely. Apply some heat. Let it cool. Great. Okay. Likewise with the black, I'm going to do that same thing, bend the wire around so that it's there. I can hold the two of them together with a single push of my thumb, hopefully. Grab the iron again, apply the heat, and boom. Done.
Wow.
Okay? So, the distance here between the actual black insulation and the connector itself, very, very tiny. Ideally, it should be as deep as this plastic insulation ring, which mine is a little bit long, so I screwed up somewhere, but that's all right. I'd be happy with that from one of you guys. Very happy. Okay? Another thing to notice is that the insulation for the actual wires is right up, if not into the cup. Why? Because I don't need to have a chance of a stray little filament from my wire shorting out with any of the other connections. Okay? So, female side is done. Female side is easier, right? So I'm going to go ahead and lock this puppy up. Right, locking it up. Maybe I won't because something's awry. There it goes. All right. So, little set screw inside. I turn it clockwise and it will tighten, but it's coming up. How does it tighten it? Well, you turn it until it has a tiny bit of back pressure on it. Don't try to over crank it, okay? And the screw comes up and locks it in place inside the shell. Good? Then I take my strain relief screws, which right behind them are these tiny little metal plates that clamp around the cable, right? So now, ideally, the strain relief takes any pressure away from the actual solder connections, right? So then when the guy puts his SM58 on the microphone cable and spins it around, it doesn't go flying off into the audience. Okay?
Probably still.
We got a funny video again.
All right, the male side, right, has the large insulator ring in it. Okay? Set screws, great. Everything's there. Shell is on the cable. Cool. Let's do it all again. So, for me, about a pinky's width. Right? I'm going to take my strippers and go around it and pull. There's my braided shield. I'm going to push down it because it's a Chinese finger puzzle, right? It starts to open itself up wide instead of be constricted. Nice, nice, nice. I'm going to start to unbraid it. Okay. Unbraiding the shield. Unbraiding the shield. Unbraiding the shield. There. Okay. You can sing if you want to. By the way, we will be playing music later today because it's not fun to be in an installation at all without music, especially if you're doing a studio install. Okay, so now that I've got my shield unbraided down to the insulation, I pull it off to one side, give it a single twist. That way, when I cut it close to the insulation, it all comes off in a group. Life is great. What do I have? I have a drain wire, and I have all the little pieces of tissue paper that, you know, if we could collect, we could make a nice Kleenex or some toilet tissue, I don't know. Okay, the strings, let's get rid of those. It should be nice and neat down at the bottom. Life is good. Now, I did mention that you could use your diagonal cutters to actually strip the wire. Let's see if I have that technique still. Why would that be important? Because now I don't have to change tools, right? Cut off the string, cut off the braid, strip the ends of the wires with the same tool. It was in my hand the whole time. Ooh, time, right? So now I'm going to pre-tin these guys up. So golden rule of soldering, apply all three things at the same time. Great. Okay. Pre-tin the shield, pre-tin the conductors. Come on, baby. Hit me. Hit me. There you are. All right. I think my sponge is losing some of its go. All right, male connector. Notoriously the hardest one here. I'm going to show you a quick little trick. Right? My stripper happens to have a little hole in there. Well, you're going to say, well, why didn't you pre-tin this? Because this one's full. I just salvaged it. Okay? Your new ones you want to fill up. Okay, pin 1. Where's pin 1? Where is pin 1? There it is. So, I'm going to start with pin 1. I'm going to go ahead and drop the shield into it. Yay! Hopefully. And I'm still shaking. And heat them both up. Come on. Great. Now, if you've noticed that your shield has started to unwind itself, this would be a great time to give it a spin, get it all tightened up, right? That way, there's no chance for it to short out against other things. I'm going to do some quick maneuvering, bending of the wires so that things end up where I want them to be. Right. And now I'm going to try to get the hot onto pin 2. Pin 2. Okay. So I get the wire there into the cup, and it's moving on me. Don't like it moving on me. And it's slightly on. Nuts. There. No, you moved. Oh, point. Ow. Hot. Abort, 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 abort. Okay. All right, final one. Black wire needs to go to pin 3. Pin 3. So I bend the black wire around so that it will make a good presentation to that particular cup. Add the heat. Bring the heat on, and it busted out. Okay. And done. Right? This one seems a little bit shorter. Great. Cool, cool. And tighten it up, tighten it up, tighten it up. Okay, and I should have a mic cable. Well done, well done. But we're not quite done. Why? Because we need to check it. So we grab the multimeter. We set it up for continuity check. Where's that? That's the musical note. Makes a beep. Makes a beep. Makes no beeps. Uh-oh. My probe lead's shot. Ah, there. All right. So I'm going to go ahead and check between pins. Let's go for pin 1 first. So I drop a probe into pin 1 on the female side, and I check for pin 1 over here. But then I need to check 2 and 3. So there's 2, there's 3. And I'm also going to check the shell. All right? Now I'll go to pin 3. Pin 3. I already know it's not going to ring with 1 because we just did that. But I need to check that against pin 2. Boop, and the shells. Finally, pin 2. We can do this. And hit the shells. Boom. I know this mic cable will work. Awesome?
Yeah, cool.
Now you can hopefully saw that all on the TU. So there we go. Go and do likewise.
Look at YouTube?
Huh?
Look at YouTube or something?
Yes.
Awesome.
I didn't bring my thing.
14